All right, everybody. Hugo Bound-Anderson here from Out of Bounds. Incredibly excited to be here today for our sixth Fireside chat to chat with Shreya Shankar from UC Berkeley about operationalizing machine learning, talking specifically around patterns and pain points from MLOps practitioners around an incredibly exciting paper Shreya and colleagues have published recently. We're going to take a couple of minutes to let everyone in. So if you wouldn't mind, while other people are joining, I would love if you introduced yourself in the chat on YouTube. If you let us know who you are, where you work, what you're interested in, where you're calling in from, why operationalizing or productionizing machine learning is important to you, that would be super cool. And we can tailor some of the conversation to your specific roles and verticals and all of these things as well. So we'll take maybe 1 or 2 minutes to let more people in, and then we'll get started. Hi, everyone. Hugo Bound-Anderson here from Out of Bounds, just welcoming you all to our October Fireside Chat with Shreya Shankar from UC Berkeley, talking around patterns and pain points from MLOps practitioners. Try to say that 10 times in a row, really fast. I'm very excited to be here today to speak with Shreya, particularly to talk around ideas in her and her colleagues' recent paper, which is about qualitative interviews and a qualitative study of what actually happens on the ground in productionizing and operationalizing machine learning. We'll get started in a couple of minutes, but if you wouldn't mind introducing yourself in the chat, that would be fantastic. Let us know what your interest in machine learning and MLOps is, where you work, where you're calling in from. I'm dialing in from Sydney, Australia. It's a beautiful early spring day here, and Shreya, who's about to join us, is in Berkeley. So I'm interested where you all are. But we'll get started in a minute or two. So if you could introduce yourself in the chat, that would be great. All right, everybody, we're going to get started very soon. Hugo Bound-Anderson here from Out of Bounds. Today, I'm here with Shreya Shankar to talk about patterns and pain points from MLOps practitioners. Before we get started, I thought just to let you know, if you're interested, you can sign up for our next Fireside Chat, which is in a month, how to build an enterprise ML platform from scratch, bit.ly/ML-inf. I'm really excited to actually spoke with Russell the other day. Russell is at realtor.com. He's worked as a data scientist, a software engineer, ML engineer, a platform engineer, and a machine learning team lead, and also built at OpCity and then at realtor.com enterprise machine learning platforms from scratch. So we'll be really getting into the nuts and bolts of what that looks like from the platform engineering side, and then kind of an overview of how these teams work together, which I'm incredibly excited for. So if that looks of interest, it's definitely of interest to me, clearly. It would be great if you could sign up. And we've got Evan Aldridge here, who just said hi in the chat. Hi, Evan. Evan works for NVIDIA, building open source software for building, deploying, and maintaining recommenders. Very exciting to have you here, Evan. If other people want to introduce yourselves in the chat, that would be fantastic. But without further ado, let's get started, Shreya. I think people have heard enough from me, and people are here to hear all of your thoughts. So if you wouldn't mind sharing your video, and I'll do the same. Hey, Shreya.
Cool. Hey, thanks for having me. I'm excited to be here.
Such a pleasure to have you here. And I thought maybe I'd just give a bit more context. I'm going to introduce you, and then we'll get started, and feel free to correct anything I get incorrect. You're a computer scientist, currently doing your PhD in databases at UC Berkeley. But before
Correct.
that, you were, I mean, you didn't go straight to grad school. You're in industry as the first ML engineer at Viaduct. You've done research at Google Brain, software engineering at Facebook as well. So you have a breadth of experience. I suppose maybe to set the scene, finding out a bit more about you. Why'd you go back to grad school after all of this industry experience?
I felt like I got into machine learning with the promise of, training models and building prediction or serving predictions to end users who could benefit from it. But what ended up happening in my job time and time again, like as a machine learning engineer, is I was building systems and I was doing engineering. I was monitoring data quality. I was reasoning about how we can keep models up to date, how we can make sure we can react to bugs with little downtime, even find them. There's like a whole plethora, right, of problems in that space that weren't necessarily the problems that I wanted to do in the first place. So I decided to go back to grad school just to study them. Can we solve them? I would love to be able to go and be an ML engineer and focus on the cool parts of the machine learning lifecycle. And that's kind of what I'm studying and how I'm trying to get there.
Fantastic. I think that provides nice context for what we're here to talk about. I'd like to know more motivation for why you wrote this paper in particular, but I'll set the scene by just mentioning a couple of sentences from your abstract. And apologies for reading your words to you, but they're for everyone else as well. We, being you, conducted semi-structured ethnographic interviews with 18 machine learning engineers working across many applications, including chatbots, autonomous vehicles, and finance. A lot of the project, I think, involved pattern recognition for what's actually happening on the ground in the space, but thinking through the process of operationalizing ML and what this actually involves, and recognizing patterns, pain points, and the variables that govern success, which we'll get to. But why this and why now?
Great questions. The actual story of what happened was a professor from a different school asked us to write some sort of repository on awesome MLOps resources. And we were kind of like, okay, that's a little bit weird because we're in academics. It doesn't make sense to write this GitHub repo, but let's do it anyways. So we were writing our draft and we thought, like, it would be nice to have something to back up, like, why should we care about provenance? Why should we care about debugging speed? These are sort of like gut feelings that we had, but we wanted to back it up with actual research. So we decided to do an interview study, and I going into it, I didn't really know how challenging it would be. My advisors had warned me, hey, like, interview studies take a year plus. And I'd come from industry where I think when we do user studies, we kind of just talk to a few people, send out a Google form, come back, get some results, and move on. But the academic way of doing things is incredibly rigorous. I did not know this. You go through multiple rounds of like finessing the questions. You go through and annotate all of your transcripts in fine detail. You make all these word clouds. You connect all of your annotations together. You have to write a paper that goes in for peer review. And I think had I known all of this earlier on, maybe I wouldn't have done it. But I really wanted to do it. I really wanted to get some like statistics or some anecdotal evidence to kind of back up what I was saying. And along the way, when I was doing this correctly, I was super surprised to find out like some of the pain points that I didn't know of, some of the myths that I had going into the study, and then some other things I learned from it, all sorts of things. So all in all, I'm super happy that I did it. Would I do another one right now? Probably not. But I think it's also separately super exciting. It's a super exciting time to be doing such an interview study because I think a lot of people are trying to build MLOps tools and are looking for some guidance on what to build, how to reach to their customers. And they don't have the resources that we do at an academic institution to be able to rigorously identify pain points across different company sizes and verticals. So
yeah,
I'm super happy
that's
about
amazing, and that's a lot of the value I get from it. I think as working for a company and working on an open source project, which is a set of tools, I find value there. I do think there's a huge amount of value for practitioners as well to recognize what types of practices actually occur. And speaking of the academic, and you may recall, and people who are viewing may know, but I used to work in academic research in biophysics and cell biology and systems biology. And so moving to industry was the opposite. And I actually remember the one of my first meetings for the first company I worked for, somebody was like, look at this exponential growth. And I was like, is that actually exponential? Could you use a log axis? And they're like, what are you talking about, man? So what I'd love to, something else we'll get to that I think is fascinating about the paper is how we're in such early nascent stages, and so much of what people do is currently unscientific for a discipline which is attempting to do science in industry. So many of the practices are nascent and evolving. So I think that'll be a really nice thing to hit on. I've got someone asking, is there a link to Shreya's paper? That's a great question. Well, the answer is yes, there is a link. And I'm actually just going to find it now in order to paste in the chat. While I'm doing that, Shreya, I'd be interested to know, maybe you could give us a rundown of the type of people you interviewed for this study.
Yeah, we interviewed people who identified with the job title, machine learning engineer. And the requirement was that they had put a model in production. And in production means somebody's pager goes off if there's a bug. So predictions are getting served to end users, and these end users are using them. It's presumably for something, otherwise the alerts wouldn't go off. And the ML engineers are sitting there in that loop, in that process of shipping models for that task. So that's the specification that we had. And we sourced people from different size companies, small, medium, large, and also different sectors, autonomous vehicles, finance, banking, recommender systems, ads, social media. Honestly, I don't remember, but it's in one of the tables in the paper. But we really wanted to cover a breadth of applications as well as company sizes. But the sampling bias here is that everybody identified with the engineer title. So they had put something in production. They had some engineering expertise. So I think a lot of different results, or some different results, might come from interviewing data scientists, data analysts, people who might not be sitting closer to the engineering side of things.
Yeah, that's fantastic. And I want to point out that this isn't to be a contrarian or to play devil's advocate, but I think because it's actually a very confusing term, that this is one very useful definition of what it means to productionize machine learning models, right? Serving an endpoint, and these types of things. Whereas you could imagine there are broader definitions where if like, let's say you use an ML model to produce a deck that informs a pretty serious executive level, multi-million-dollar business decision, that's operationalized in some sense, but it isn't what we're talking about here.
Exactly. I think the key here is that these predictions are sustained over time. They're not a one and done sort of thing.
Yeah, fantastic. I'll also mention, people are saying things in YouTube chat, which is great. If you have any questions that come up, please do ask them and we'll try to get to them. We're also having an async AMA over the next week or so. And so I'm going to post a link to our community Slack. And if you want to join that, the channel AMA guests will be having an async AMA there. And any questions we don't get to today, we'll try to get to there. But definitely ask questions in the chat. So I'm interested in what you discovered in terms of, I mean, at a basic level of pattern recognition, just what the main tasks that people do in the production machine learning lifecycle are. What did you find out?
I think a good answer to this is what the textbook says, and then what we found that is different from what the textbook says. And what the textbook will tell you for machine learning is, first you collect data, step one. Step two is you train a model. Step three is you evaluate that model on a holdout data set, make sure there's no overfitting. And then step four is you deploy. And what we found is that we can still categorize into 4 steps. And maybe the data collection part is similar, except for it's more of a loop. Like every, week or so, we want to collect new data. We want to make sure there's some QA on that data or something. But the rest of the steps, the last 3 steps, are totally different. The second step, what I said before, model training, is actually experimentation in general, whether it be training new models, whether it be trying to source new data or adding new features. There's a lot of ways you could think about improving a model. And a lot of the participants actually preferred to look into finding new data that gave new signal, or making features more fresh instead of stale features that they had before. So that's kind of step two. Stage three in the process was we call evaluation and deployment. So evaluation is not a one and done thing. What happens is evaluation is kind of done maybe on a holdout data set at first, and then it's deployed to a small fraction of users. And then when the model shows a little promise there, increasingly it's deployed to more and more users. As we learn more about what it can do, what it can't do, what failure modes exist, how do we go and patch problems until we've kind of gotten to the full population. So key takeaway is evaluation is not a one-time thing. It is a loop on evaluation and deployment, a multi-stage deployment. And then the latest, step four we found was this overall monitoring and response stage, which was when you do have these models in production, what is their live performance? If you see the performance dropping, what are the bugs? Where are the bugs? How do we respond to them quickly? Whether that be actually trying to go do root cause analysis or simply retraining the model, there is a stage around making sure that there's little downtime for these services. So we have those four stages shown in the first figure in the paper, and it was interesting to several of us authors that they don't match the textbook. I think that's like kind of the narrative that we want people to take away.
Absolutely. And let me ask, are these different steps? I mean, there's an iterative loop happening there, but are they kind of coupled in some way? Because you could imagine monitoring and validation aren't always separable, right?
Totally. I'll say that monitoring is kind of done across the stage, or kind of in all of the stages. People monitoring their training jobs, people monitoring data collection. A lot of the times there's human in the loop processes to collect and label data to verify some quality. Whenever you see a failure on the ground, to go and collect examples that look like that failure so you can go back and augment your validation sets. So in that sense, there's monitoring all over the place. But the one stage that we found that was super iterative in itself was evaluation and deployment. Evaluations data sets never stay the same. They're always changing, they're always growing, especially in tasks or domains where failures have such a high cost. Like autonomous vehicles are a great example of a failure is a really high cost. When we observe one, we need to make sure that we have no more failures like that. So how do we go and invest efforts into making sure our holdout data sets, whenever you evaluate your models, new models in the future, they're also robust to the problem.
Yeah. And I suppose drilling down even a bit more into data collection, and I think this is one thing that you're getting at. In textbook data validation, you're given a holdout set, right? As opposed to be actively getting that data and validating it and making sure it's the right data, then using it as a validation set. There are feedback delays there. All of these
totally
things, right?
Totally. I feel like I was never taught this in a machine learning class. Nobody taught me how to actually evaluate a model. It's not like I need a big checklist. I just want to know, if I were to be a machine learning engineer for a month, not just one time, what do I do about my validation set? Do I keep it the same? Do I grow it? When do I add to it? What do I add to it? I think this in itself, super interesting problems for people to consider.
Yeah, very much so. So something I'm really excited about is you've identified 3 key properties of ML workflows and infrastructure that dictate how successful deployments are.
Yeah.
What are they and why are they?
So we have these 3 Vs. They're not even related, or we didn't even know about the big data 3 Vs. Joe was telling Rolando and me, hey, there's big data 3 Vs. Are you sure you want to make 3 Vs? And then we were like, oh, shoot, we shouldn't make 3 Vs. But then on second thought, we were like, I think it's cool if we say that we came up with these 3Vs independently because it kind of highlights the synergies between
Absolutely.
machine learning and traditional data.
Yep.
But these 3Vs are velocity, validating early, and versioning. And why did we come up with these 3Vs? We wanted some way to explain kind of best practices and pain points we were looking for patterns in what our interviewees said. And since we asked such open-ended questions, they're in the appendix, but we asked open-ended questions like, tell me about a bug you had last week, something that caused you things like that are so open-ended. They're so hard to extract patterns from. So it helped us to come up with these variables like velocity. People kept mentioning that they needed to iterate quickly on experiments because they had a large frontier of ideas to try and they wanted to see something that would give a production lift. So we wrote down like velocity, velocity, velocity. When we were looking through our codes at the end of the day, we were like, oh, when people are doing experimentation, they care about velocity. And it really resonated with us when we started thinking about MLOps tools. What makes an MLOps tool successful? Well, experiment tracking is a nice space because it really 10x's your experimentation velocity. Now, I don't have to go copy paste into Google Sheets and back. Maybe that works if I'm the only person working on my model. But at the moment that multiple people are working on an ML pipeline or model system, then it's super nice to centralize all of the experimentation we do so we can share the knowledge that we've had. So we had velocity for that. For validating early, a lot of people complained about the fact that at their organization, either too many bad models made it to production, or so that was like it was validating too late, or models were validated way too early and that they couldn't get anything to production. So for one example, in an autonomous vehicle company, the cost of deploying a bad model is so high. So they incorporated all these checks. They made evaluation take much longer. They decreased the velocity and engineers were grumpy. But at the end of the day, I think there's a quote in the paper that says that, we'd much rather gate the velocity if it means that we don't get failures on the road. So again, different tasks, they have different priorities and I think that's also why people keep talking about how like machine learning, it's not even generalizable. It's so different for different tasks. And when you think about it through the lens of these Vs, it's not that if it makes total sense for different tasks, they just have different priorities. Some people prioritize velocity over validation if it's like a Rexus problem or something where the stakes aren't so bad if there's a failure.
For sure.
So in that sense, we really liked this kind of framework of evaluating tools, evaluating what people cared about. And as people who like to build tools ourselves, there's some tool ideas that I've had that now I can confidently say that, oh, this is really not a 10x improvement in people's workflows. It doesn't really help their velocity. It doesn't validate better. And it doesn't help people manage any more versions. So why bother? And I really like that way of thinking about it.
Fantastic. I want to get into, it's so great that you've identified these three key concepts. I want to get into the trade-offs, tensions, and synergies between them. But before that, I think velocity and validation, we have a strong sense of what that means now. I think practitioners probably know enough about versioning, but I think a lot of people who haven't delved deep into this know about versioning code, but they're not sure about versioning models and versioning data and these types of things. So what are we actually talking about when we're talking about versioning in machine learning?
Great question. So versioning is across the entire workflow. And the way that I like to think about it is when you have higher velocity, when you are iterating through different ideas quickly, now you have different versions of things to manage, to keep track of in your head, to keep track of in the system. Whenever you are deploying models, every time you retrain a model, that's a new version. Every time you get a bug report and you decide to implement a new rule to prevent against future bugs, now you are effectively maintaining a separate version of that model. A great example is people love to use off-the-shelf language models, but when incorporating that into their products, like a customer support chatbot, for example, sometimes these language models will hallucinate things that are obviously wrong. Like if there's this great anecdote where some end user asks like, what time is the store open? And the language model will output it will hallucinate some time. It will not be the right time, but it will say some time. So what you can simply do is put a rule that says, if there's a time in the output, don't return it, or like go return the actual time or something like that. But so this is great in that it prevents against future bugs. But what does it do? It adds a new version of your model for a particular input. So maintaining this versioning bloat is hard to do, especially as versions only grow over time, right? People are not removing from production. Nobody is saying, let me delete this rule that I used to have before. Nobody wants to touch anything that works. So how do you maintain this over time?
Fascinating. I think one other question is, when we classically think about versioning code, it's human readable, right?
Yeah.
Whereas versioning model, like what are we even thinking about? What are we interacting with, like run IDs and task IDs and that type of stuff, and maybe dashboards resulting from it?
Yeah, and I'll argue that run IDs are not the way to think about versioning. Cognitively, like I'm not going to look at a list of 10 UUIDs and like know the difference between them. I think at least talking to the interviewees, right, it makes sense to think about versions in terms of, oh, this model version kind of handles this edge case. This model version handles this case. This is the simple model version for when our main production model fails and we need to roll back to something simple. This was last week's model version. So again, right, you could have all the models in the world, but if you don't have a way to really to look at it and understand exactly what it does in your brain, then it's really hard. And I think this is a mistake a lot of model registries try to make, which is like show all the UUIDs in bold letters. I don't know what to do with that information. Maybe somebody else knows, but that's exactly what you said, right? Code, when we see code versions, we can look at diffs. We know what's the difference. Yeah. What does that diff mean to us in the data and the ML space?
Yeah. And I love that you mentioned rolling back. And I do want to get back to a broader vision of the 3 Vs, but we may as well just drill down a bit more now. I'm interested in the different types of if something goes wrong, do people have something which they can always roll back to? You mentioned this idea of shadow models. There are also challenger models. What are all these different things that people are working with when they're doing all of this experimentation and then deployment?
Yeah, depending on the size of the company or kind of how critical the ML pipeline is to the business, there can be thousands of versions of the same model. So to give you an example of like a really, really large company, every data scientist is kind of like running a live experiment or an A/B test, 1 or 2 at least. And so there's that many versions of the model going on. At a lot of these companies also, and not just the big companies, there's like a backup model that people have, just because I think there's one quote in the paper that's like, we will switch to an less economically viable model if it means that there will be no downtime, right? Like you just cannot afford to return nothing. You can't afford to return absolute garbage. Like a lot of times what happens with the performance is like suddenly it might tank. And then it might tank to something that's worse than the baseline simple rules. But at that point, right, you want to have the baseline rules there so you have something, not nothing. And I think like the more mature a company gets, right, and like the more more end users they have, like Facebook cannot afford to go down. They'll have something there. They have many, many models to make sure that like there's always something to roll back to for almost all of their prediction systems.
Yeah.
But again, that versioning bloat is unbelievably hard to manage.
And what's a shadow model?
So some applications can do this and some can't, but the idea is to have a model making predictions on live data as the live data is coming in, but you don't surface those predictions to users. This doesn't work very well when you require user feedback, like in some recommender systems, where there's like a loop where the human kind of influences the algorithm, vice versa, in such a short period of time. But I've worked on cases like in predictive maintenance is a good example of like I'm predicting when parts of vehicles or parts of the computer or any equipment might break. I could kind of make predictions in the background and then a few weeks later check how did those predictions do. And a nice aspect of shadow mode is that it it removes or it you can't have like any assumptions, or maybe I'll phrase it this way. A lot of times when you develop models, you might have some assumptions about the data that don't quite exist live, and feedback delays is one of them. So when you are deploying models in this shadow mode, you minimize that assumption gap. Like you're in the prod environment, you're there, you have access to what the prod model will have. So that's good, but it only is applicable in certain tasks.
Yeah, great. You mentioned in the paper, this is something we hear all the time, that 90% of models don't make it to production or something like that. That's one of the most cited, whether we know it. It's like, 80% of data science is preparing data. So it's one of those things, right? But it's believable. But you make a point, I don't know whether you make this, no, you make it explicitly, that this is something that's often stated as a negative. But let me ask you this, if 90% of models don't make it production, is that a good thing or a bad thing?
I don't think it matters. Like what matters, what more mature ML companies and teams will say is, as long as the experimenter can go from idea to results as quickly as possible, it doesn't matter if there are thousands of failed artifacts in the process. Like if I'm running 10,000 experiments in parallel, which I would never do because I cannot keep track of that, somebody probably would. If I'm running 10,000 different tuning jobs in parallel and 9,999 of them fail, but one of them succeeded, that's gone. Like, that's great.
Absolutely. Yeah. And I think, I mean, we forget that science is about failure. I mean, Max Planck or whoever said science progresses one funeral at a time, something like that. And I mean, that's so true. I mean, science works through invalidating hypotheses and then promoting the ones that we're most certain of, quote unquote, right? However you want to quantify that, if you even do quantify it, which a lot of the time we don't.
Totally. I think that's also to the point that like velocity is super important. And then how do you validate early so you don't waste time on projects that will fail, right? I think that's the thing to care about. If there's something that is destined to fail and we know that, or we have how can we estimate the likelihood that something will succeed or fail pretty early on and then ditch the project if it's going to fail?
Totally. So this is great. Now we're getting back to the three most important aspects that determine the success of operationalizing and deploying ML: velocity, validation, and versioning. You make it very clear that, I'm going to actually quote you, high velocity means creating many versions. In other words, having high velocity means drowning in a sea of versions of experiments, right? So I'm envisaging there some Pareto front where there's a tension and trade-off between velocity and versioning. But then you also mentioned there are synergies between velocity and validating early. So if ideas can be invalidated in earlier stages of deployment, and overall velocity is increased. One more thing you mentioned is creating similar development and production environments exposes a tension between velocity and validating. So the development cycles are more experimental, move faster than production cycles. However, if the development environment is significantly different from prod, it's hard to validate ideas early. So we have this, there's some sort of Pareto triangle with synergies as well. So I've mentioned a few, but can you just speak a bit more to the relationships and correlations and causations between these three incredibly important things?
Yeah. I mean, the paper, you probably listed like most of them in the paper. Those were kind of the ones that stood out to us, mismatch between dev and prod. I think the nice anecdote there is on Jupyter notebooks. For a long time, We had all been seeing each other. Some people so excited about Jupyter Notebooks. Some people absolutely hate Jupyter Notebooks. Everybody has strong opinions. Everybody wants to give a monologue on their opinions on Jupyter Notebooks. And I think for me, it's been like so many years of hearing this kind of over and over again, why people love it or hate it. And I wanted to know why it was so polarizing. And it was very satisfying to me to hear this, or to kind of frame it as this kind of where do people lie on the velocity and validating spectrum. Some people want to move fast and break things in the Facebook speak, and they're okay with that if they can fix it. Some people do not want to move fast. They want to make sure that there's no buggy models. They want to make sure that everybody can review each other's work. Yes, that hinders velocity. And kind of like, it's really hard, right? Some people want Jupyter Notebooks because they can go fast. Some people don't want data scientists to go too fast, because then maybe certain scientific principles are disregarded, maybe things are irreproducible. I don't really know, but it was nice to frame it this way because there's no right answer, right? It's like, where do you personally lie on the spectrum? And when you run a company or you run your team, like, what is the ethos that you want to create? Or like, where do you guys want to lie?
Amazing.
That was interesting to me.
This is incredibly useful. I mean, this framework. So what I'm hearing is, in this framework of velocity validation and versioning, we can look at people who prefer Jupyter Notebooks, and in this framework, they're essentially prioritizing velocity. Whereas people who are strongly opinionated against Jupyter Notebooks are prioritizing validation and versioning, or mostly validation, or how do you think about that?
Mostly validation. I think of it as validation more because it's like, how do you how do you make sure the development and production environments are as similar as possible?
Yep.
Whenever there's a discrepancy, there is chance for bugs. So you can remove the need to validate a lot when promoting from dev to prod if there is no real like environment change from dev to prod. One great example is like, sometimes people will iterate locally and then deploy to the prod service in cloud. That is a huge environment mismatch. So you need to do some sort of big validation. I don't even know. I don't think people have solved this problem of like making sure there aren't bugs in this mismatch of environments. But again, right, like why is it so separate? Like, it's completely different hardware, not even in the same like cloud. Crazy. I think this also exposed to me that like I am now feeling somewhat opinionated. It's not there's no correct opinion, right? It's like, what is the opinion you want to hold and you want to prescribe for the team that you are running?
Yeah, absolutely. And a question around notebooks, for example, is if they don't have affordances which we'd like them to have, maybe as tool builders, we build them into them as well, right? It isn't yes or no, it's how do we want to build the future as well, right?
Yeah.
As you point out.
Totally.
We have a really interesting comment from Evan Aldridge, who Evan's a NVIDIA building open source software for building, deploying, and maintaining recommenders. Evan wrote, with respect to models failing or experiments failing, it's key whether it's failing because you're invalidating a hypothesis or whether there's an engineering failure that prevents the model from ever making it to prod. And that just reminded me something that I found fascinating in your paper. You know, in machine learning, we think about hyperparameter tuning all the time and that type of stuff. But you made it clear that a lot of the time you can get bigger wins from other parts of the pipeline, as opposed to, you know, just spending GPUs on hyperparameter tuning on some massive grid, right?
Totally. I guess to Evan's point about the engineering, so many of the participants and even papers, like, it is not new news that engineering bugs are largely the cause for kind of production model failures. Like a data pipeline didn't run, or now like a lot of columns are null, or you ingested a data set that you usually ingest, but somebody swapped two columns. Happens all the time, right? Like, silent failures make their way to garbage predictions. And like that also gets to the data validation pain point that I talked about, the Goldilocks thing. in the paper of, like data doesn't need to be 100% pristine and perfect going into machine learning models, but
Mm,
it shouldn't be zero. It shouldn't be total garbage. So what is the sweet spot? How do you identify this? This is, of course, different for different tasks. And then in one, I'm writing a paper on automatic data validation right now. It's even different at different time periods. Like the company that is also writing the paper that I'm consulting for, that we're writing the paper together, they're saying like, oh, around like Thanksgiving time and the holiday time, we need to make sure that like we don't have failures. Like we don't care if there are more false positive alerts. There just can't be failures. And now I'm just like, oh my God, like how are you supposed to build a system to satisfy? How are you supposed to build
absolutely.
an automatic data validation system for all sorts of tasks, all sorts of data sets? For that's like a tunable depending on who is on call, literally, and what time
Mm,
they're on call.
yeah,
Like,
fascinating. So we have another question from Shrinand, which I'll get to because it's actually around tooling and evaluating tooling. And I want to spend a bit of time at the end talking about tools. So just to foreshadow that, Shrinand, we'll get to your question. It's a fascinating question. You mentioned kind of the role of data in these models, and you hit on this in your paper. But I'm interested if you could speak to what you've seen with respect to the differences between, I suppose, the data-centric machine learning paradigm and the model-centric. And this comes back to your point about what's taught in textbooks and what's taught on, I suppose, online, on like all the competitions we do and that type of stuff also.
um, yeah. So, I mean, I think the textbooks, at least courses now, I don't know about textbooks, are talking about data-centric AI. But the premise is flawed. It's the same premise that people talk about model-centric AI, and that by hook or by crook, we will edit model hyperparameters until we get something that works on a small validation set. And
Mm,
people are doing the same ethos when it comes to data-centric AI. By hook or by crook, we will add 3 or 4 examples or remove 6 of these labels or clean 12 of these labels, and we will get 1%, 5% better performance on a validation set. This is the same ethos. Like maybe this is easier to do if in the data-centric sense, but then it's in the model-centric sense. But we found in the interview study that this is not at all the way to get lasting wins, right? You want to get a win that lasts beyond the initial validation. And we talked about this thing in the section around experimentation, where you want to find ideas that lead to huge gains in the first offline validation because there's diminishing returns in successive stages of deployments. Like in the offline validation stage, if you get a 15% boost, or I don't, that's kind of high, but if you get like 5% in the third stage of deployment, later on, it's only going to be like 0.5%. So account for these diminishing returns as you go down. All of a sudden, like now that changes the way you think about your experiments. Like, what can I do to bring long-term gains, right? It's not about editing the view of data that I'm training my model on. I want to add new signal. I want to go find a new data set that will add new signal to the
mm,
model. I want to fix engineering problems. I want to add data validation so I don't retrain on corrupted data. Like these are the big wins that give you the long-term boost, right? Over the, I hesitate to like preach about data-centric AI in the way that it's taught. Um,
yeah,
I don't love it, but curious what other people think.
yeah, great. Um, so I now want to jump into, you talk about a lot of the pain points, and I think sharing stories of suffering is incredibly important for all of us civilizationally, but particularly in such a nascent field, right? What are the biggest pain points you've noticed and your colleagues faced by people deploying machine learning models to production?
Yeah, the ones we talk about in the paper, um, kind of echoed by all of the interviewees, mismatch between dev and prod environments. A lot of bugs can be traced back to this, like the label delays, data leakage, all sorts of things. Um, Another one being kind of data validation. There's way too many alerts that engineers get when they're on call if they're monitoring models. Like if we put some CloudWatch alerts on every single feature for a model, the probability that at least one of them goes off is insanely high. And as a result, people will say things in the interview study like, we ignore 90% of alerts. So that's another pain point.
So these are
Goodness.
false positives, right?
Yeah, false positive alerts, where it's like I get an alert that a feature has changed when the resulting model performance is like still kind of the same.
This is incredibly important because this isn't, I mean, we talk a lot about the technical stuff. We don't always talk enough about the human side. I think you maybe even mentioned the word trauma associated with high false positive, but no, it's really important to identify trauma in a discipline, right? If people can't do their jobs and are getting spooked constantly because of this.
It's totally, spooked is a good word. People were saying how like they dread going on call. Some teams require two, like larger models will require two people on call at the same time, like a primary and backup, because it's just too much. It's too much responsibility. It's too much onslaught of information. Recently, I was talking to someone about, someone was saying like, oh, also in the software, in the SRE world, we also get way too many alerts. We get so many CloudWatch alerts. And I was like, yes, I know. I've gotten both of the alerts. The difference between the SRE alerts and the ML alerts is that you can over time develop a sense of which SRE alerts to ignore. But you cannot do this in the ML setting. The important features are always changing. If I move to a new ML pipeline, everything is different. I have to relearn, like, what's the data look like? Where are we getting the most signal? What are the most important features? Like, what if it's not a tabular model? What if it's an image thing? Like, all of my old knowledge kind of goes out the window. You can't like really anticipate what like alerts you can ignore, what you have to listen to, and then there's no fix, right? It's like sometimes, you know, like some pods are down and they won't come back up, and like I know how to fix that. But sometimes if customers are complaining about low quality ML predictions, I don't even know where to go, right? Like I could be a veteran ML engineer, I wouldn't know where to go. And that's also another pain point, was this like taming the long tail of ML bugs, I think is what we said in the paper, which is people will spend so long slicing and dicing and trying to figure out where a bug lies, only for it to never happen again. Some other thing of similar magnitude, same debugging pattern, same time it takes to debug, completely different bug. And it doesn't get better, right? So how do we think about making this experience better for people? I think at least my personal interests are around like how there are always going to be humans building and maintaining these ML models. How do we make their experience better? That's how I approach the like pain point thing.
What's the role of subject matter experts and domain expertise in building and operationalizing models from your research?
Totally. We didn't explicitly ask any of these questions, but many people voluntarily said, like, when I asked, like, oh, like, what do you look for when you want to try a new experiment? How do you get an experiment idea? A lot of them ping subject matter experts on Slack, or they talk to people. Anytime, this goes back to validating early. Get as much signal as early on in the workflow as possible that this experiment will be a good experiment. Like there's no wins around I came up with this idea myself, right? Like a lot of times companies will have like UX researchers, data scientists that are very familiar with the data or the customers or what people want. And it is really helpful to be on the same page. I talked to someone there was an interviewee at a mid-sized company who said that their personal productivity went up so much when they got a sense for what the product metrics were that were being evaluated around like click-through rate. And sometimes it wasn't just click-through rate. It was like how long somebody spent browsing the recommendations, all of the recommendations. And these are two completely different product metrics, but we think about the same ML metrics for recommender systems, right? But if you have a good sense of the product metric that the team is being evaluated on, right, it's easier to come up with experiments that could really win in the end. So I think, yeah, the role of subject matter experts is very important, but it's not just SMEs, right? It's broader than that. It's people who are familiar with the users of the system, people who are familiar with the data. As ML engineers, we cannot do it all, right? We cannot know everything. We have to leverage information.
We can't even figure out dependencies. Yeah. So, how can we be expected to? No, yeah. Of course that's tongue in cheek, but you're absolutely right. And I'm so glad, and I wasn't sure we'd get to this, but I'm so glad you mentioned the emphasis on making sure that we're evaluating our models with respect to product metrics, which tie it into creating value for whatever organization we're at as well, and make sure that all of these things are as matched as much as possible, and that we continually evaluate them is incredibly important. Something we've been dancing around is software engineering, classical, traditional software engineering, and machine learning engineering. Same or different?
Oh, it's if I say something, I'll offend somebody. No matter what I say, I'll offend somebody.
We've already talked about notebooks, serious. So we've clearly offended both. But we have to offend everyone if we're going to offend someone. So that's the rule.
Okay, so I guess this is a nice preview for my NormConf talk. It's going to be on all of my machine learning problems or data management problems. So I think, so maybe that's how I feel about kind of engineering. And I don't think it's like software engineering per se that is really like the skill set that an ML engineer needs to have if they want to be a 10x, to use that stupid term, 10x engineer. But I think it is an understanding of how data works, and what is a data pipeline, what is a table, what is a relation, okay, and what is a view. This is a nice one. A lot of people don't even know about views. It's fine. A view is kind of, I run some query on a data set, I just store that as a view that will either be materialized before I query the view, or it'll be materialized as I query the view. Okay, so there's like a question of like, when do I materialize the view? This is the same problem in machine learning. If you think of a machine learning model as the view over the underlying training data. Okay, when I train the model, that's when the view is materialized. So all of the problems around view staleness are the same thing. There's a model staleness. Okay, we don't want to compute the view on wrong data. We don't want to train the model on incorrect data. These are all the same problems that we have been talking about time and time in databases that are showing up in the ML world. So in that sense, like, I think ML engineering really is just like recasted data problems.
Yeah, fantastic. And anybody who, I mean, NormConf is a free conference. It's happening online. I think if you look up NormConf, you'll find it. And I think, correct me if I'm wrong, but the premise there is that a lot of people talk about things that aren't particularly relevant. Like a lot of the conversation is live action role playing. So what actually happens on the ground, essentially. I don't know if Vicky would refer to it as LARPing, but that's my take on it.
I feel lucky that Vicky is letting me give this talk, because I was supposed to give a practical talk, but my talk is very like, a lot of people don't even know how to reason about machine learning. But my argument is that you definitely know how to reason about machine learning if you know how to reason about data.
Yeah,
or data pipeline.
That's a beautiful. I'm definitely going to quote you on that. So I want to get into tooling. I think it'd be a nice way to. And of course, we talk far too much about tooling in the space. And there's the old joke: we have far too many tools and not enough at the same time. But I'm interested in what you discovered around tools, and maybe we could frame it around Shrinan's question, which I find fascinating. I think about far too much. I mean, I lose sleep over this. There are a lot of tools present for these problems being mentioned: versioning, experiment tracking, etc. Do ML practitioners truly try to evaluate, learn, and adopt these tools?
Great question. If an ML engineer is truly trying to the best of their ability to evaluate, learn, and adopt the tools, that means they're not doing their job. They're responsible, right, for pipelines in production. They're responsible for responding to bugs. They are responsible for they're fighting fires 24/7. And this tooling industry is not something, if they don't know 100% that this tool will help them fight fires, it is an absolute waste of time to try this tool, especially because there's a lot of tools out there. And I think that a lot of people think like, oh, ML engineers are lazy. They don't even want to try my tool. It's like, no, I'm not confident that your tool will 10x my velocity, validation processes, or ability to manage versions. 10x, like not just slightly, because it takes time to integrate things, right? Everything is glued to each other. At least that's how I reason about tools as a tool builder and ML engineer. I've been on both sides. So yeah, as an engineer, could I definitely spend more time using tools? Yes. Will I not get promoted? For sure. So like,
No.
I don't know what else there is to say about that.
And we've mentioned this several times, when we're talking about 10x, are we now talking in terms of velocity of actually deploying models, time taken to deploy and then iterate, essentially?
Yeah, that's one of them, right? Like if the tool really increases my experimentation velocity, awesome. Like a lot of people, that's a time sink. If the tool makes sure that I never train a model on data that's corrupt because of engineering bugs, that's amazing. Like so much of my time is wasted as a practitioner, like figuring out what engineering bug caused my ML model regression. I almost rarely feel like the tools are really designed to alleviate my pain points in that way. I feel like a lot of modern tools are like, look, here's something that you can glue to your existing jumbo ball of tools that may or may not provide you with anything. Like, I don't know.
So what then? I think this is a nice-ish note to wrap up on. What then are the biggest opportunities for future MLOps, for lack of a better term, like MLOps tools, tool builders, and research?
Yeah, please read the paper for all of the takeaways. Like I bold takeaway and then I write takeaway. The ones that I am particularly excited about research-wise, because I need to get a PhD, I'm interested in an interface for a hybrid rule-based plus AI system. A lot of times, right, we deploy models and we tack on rules to it, and these rules are often glued. I would like a framework as a first-class citizen. I can define these rules in the way that I define models and compose them super easily. I think that's one very interesting way of thinking about like these evolved ML systems. But that's maybe more researchy. More practically, I think that there's a lot of low-hanging fruit in the data validation space. I know there's a ton of ML monitoring companies out there, but they don't seem to be solving this false problem, alert fatigue problem. Like think about it that way. How do I make sure that there aren't that many false positives? I can recall 90% of failures while maximizing precision. How do I do this in a model agnostic way? I'm writing a paper on this, so like that essentially will be solved. I'm trying to think about other, I don't know, like I think there's so many things that you can think about, like around validation, around helping people construct dynamic validation sets, right? A lot of companies will have these like folders of validation data that they just add to because analysts are adding to it or labelers are adding to it. But how do we make it easier to manage these, to version these as these data sets grow? I think there's so many things, right? We can do just a few.
Absolutely.
Please read the paper for more.
And data has a half-life, right? There's some decay at which its relevance decreases, right? And that's one of the many reasons.
Thank you.
Yeah.
Data management. All of the problems are data management problems. So.
Absolutely. So we've got Evan from NVIDIA has another great question. Any advice for tool builders to design tools that provide that 10x velocity? And he makes clearer, we try to build those principles into Merlin, for example, by thinking about not just the speed ups, but the workflows of the engineers.
This is a great question. And some of my collaborations with non-technical folks in the lab, where we're kind of building ML tools, we're seeing that there's some slowdown when people are moving between different tools. Like, for example, people will write code and then they'll write in their Google Doc or they'll write in their spreadsheet. And it takes time to context switch between these things, all in the name of experimentation. But how do you remove that context switching? One-stop shop for when you have the idea to like when you get the result. I think that's very interesting.
Yeah, absolutely. So it's time to wrap up, which is, I mean, I'm enjoying this so much, but we'll have opportunities to chat more in future. I think it'd be nice to wrap up with not necessarily about this work, although if it's relevant, it'd be nice to know about that. What my question is, what are you really excited about thinking about next? Yeah. What are you working on currently? What's most, you know, what gets you jumping out of bed in the morning, excited for the day in the ML space?
In the ML space, I'm like, I don't know if some ML is getting me jumped up. I think like as I'm wrapping up this automatic data validation, I mentioned I'm excited about like interfaces for hybrid non-ML and ML systems. I think every system is going to be eventually like a combination of the two. And not just interface, like interfaces are an interesting question. Like a lot of people talk about how prompting is supposedly a query language. It's absolutely not a query language. There's no semantics given on it. But people, why is it that these like language models don't have any practical use? They're not being used in businesses very much, with the exception of a few. We need some way to provide like some semi-formal guarantees on semantics. So I'm super excited to think about that. And then once that's kind of semi-formalized in a way, what does it mean to run queries, to optimize queries? I love query optimization. I'm a databases person. So I think there's all sorts of interesting technical problems there that I'm very excited to think about.
Fantastic. We've just got a comment. Evan says, thanks so much. Always great to hear from Shreya, which is nice.
Thank you.
And for those interested, we're going to wrap up now, but we'll have an async AMA on our Slack, an AMA guest. So if you want to join, Shreya and I will answer questions async over the next week or so. Shreya, thank you so much, not only for your wonderful paper and work, but for joining me today. It was such a fun conversation. I really appreciate it.
Thanks so much, Hugo. I enjoyed being here.
Awesome.